मैंने बहुत पहले आपकी बात करी है 2-3 बार चैनल पे कि मेरे एक सीनियर थे, शुरू में GSoC पढ़ाया था, तो मैं तभी बोला था कि जब भी मुझे टाइम मिलेगा मैं उनको बुलाऊंगा।
क्या हाल है? कैसा है? वो अवार्ड्स अवार्ड्स भी थे ना तेरे पास, क्या नाम, वो सिल्वर फिर गोल्ड ऐसे चलता है कुछ। हाँ, हम लोगों ने टोटल 100 मिलियन रेज किया हुआ है।
अमेजिंग। बर्न कहाँ हो रहा है उसका, या फिर मतलब वही मॉडल्स में
कंप्यूट
जा रहा है?
कंप्यूट हाँ, वहीं जा रहा है मोस्टली, वो पेरोल। और बाकी सब कैसा चल रहा
सब फर्स्ट क्लास। आप बताओ, हाउस बे एरिया कैसी रही आपके पिछले फ्यू ईयर्स?
है? बढ़िया यार, बिजी बिजी चल रहा है।
मैं देखा रेस तो काफ़ी सही कर लिया था आपने, मतलब वेरी वेरी इम्प्रेसिव।
एआई टैलेंट काफी एक्सपेंसिव है और हमारी सारी टीम यूएस में ही है मोस्टली।
लाइफ में सपोर्ट सिस्टम होना बहुत ज़रूरी है, सो है क्योंकि वही बाद में काम आते हैं।
Hi everyone, and welcome to a new video. Today we have Aman with us. Aman is my 2 years senior, the mentor I've talked about for a while on my channel. I'll briefly take you through his journey and then he can elaborate more. But he's 2016 graduate, I would assume then. College में he did GSoC 3 times. Also did an internship in Bay Area, मतलब international internship that he found on campus, off campus. Sorry, he's from electrical. तो शुरू में he was doing a bunch of things. I remember first year में I don't think he coded too much. First year के बाद, or in the middle of first year, he got into lab, started coding, started liking it, and then sprinted really quickly. When I joined lab in my first year, he was 2 years elder to me, so we were interacting for around 2 years जब तक वो कॉलेज में थे. And during this journey, he was the initial person I showed my bad pull requests to. He guided me through GSoC, मेरा पहला GSoC. More or less मैं attribute सर को और एक और सर थे हमारे दिवित सर, उनको करता हूँ. तो very interesting close senior of mine since college. And one very intriguing thing about him was he did not sit for campus placements. It was very obvious to him that he's going to go for a master's or a PhD, and he did that right after college. Even though his CGPA was really bad, I remember that he was struggling with admits back then. But he got into NYU, and NYU is pretty decent, has decent professors for MS and PhD in AI. Back then, somehow he had the prediction that ML is going to do well. So I think his master's was in machine learning. And he just told me he wrote a bunch of papers during his master's. Right after master's, joined Facebook in their AI research lab, worked there, did a bunch of papers there, then wanted to start up. When he wanted to start up, he moved to a startup, Hugging Face, which is one of the biggest AI startups today. Worked there for a year and then eventually started up himself. In the last 1 year in his startup journey, he's raised around $100 million. And he told me he has around 20,000 citations on his papers until now and has published around 25 papers. So that's the context. With that, Aman, did I miss anything?
No, I think you captured everything. Hello everyone.
Would love to know your journey from this top. के college में how did you peak so much in your learning, and considering you were from electrical?
Yeah, I think the most important point in any kind of thing that you want to learn is that you have to execute. So if you don't execute and just read, you will not learn much. So I basically focused on executing a lot, like taking open source repos, like trying to make pull requests to them, taking bigger code bases, trying to understand them, and like trying to see like how people actually code on bigger patterns. And then of course labs helped a lot, right? We have like very creative projects, as you know, and we have done many of them that helps you like guide through the process of like how to start an idea from scratch, implement and design like the philosophy, the user experience end to end, and then actually implement and take it to the public that is using inside the campus. And we also had some projects which were like public to all of the public, not just inside the campus. So that was good motivation overall. So I think general philosophy for me in life is that if you want to learn something, you have to get hands dirty. You can't just like learn by like looking at the blogs, but not actually executing it. Because there's so many nuances that you get to know once you start implementing something. Without implementing it, you will not get to the level of detail that you want to be. So it's very good to have breadth in certain amount of topics. Like you need to have breadth in most topics. That helps you like make better decisions. But when you're going for depth into something, you have to actually go in and actually do something very impactful there.
Super interesting. I think that's a great point. But a lot of people struggle with कि they want to read bigger code bases, they want to look at other people's projects, but वो थोड़ा सा देखते हैं and then they leave it. So how did you? Do you think you're inherently smart? Your IQ is high, or is there something else?
I think it's just hard work and perseveration at the end of the day. Like you have to have grit. I think grit is a very important aspect. Like if you fail, I think there's another aspect there. Like you should look out for mentorship and advice from people. And you will be surprised how many people are actually ready to help you out with things. People are like very generous with sharing their own knowledge with others, and people like to do so. So I think having right mentors in place and right advisors in place as you grow through the career, and I've been very like lucky with having many of them as well, growing at the right time at the right moment, that helped me go through this journey, and I'm very grateful to them. So having that as a first place and having that core set of people that you sit around, because you get as better as the people that are around you, right? So that's why labs was a very good environment. Like we have very smart people in there who were already ahead of the journey than us. So you basically, there's a concept called reverse osmosis, where you're just sitting in the lab, you learned a lot that you wouldn't learn if you're sitting in your room inside, like Rajiv Bhavan or something, right? So it's very important that you stay in a circle of people that can help you through these hurdles of everything. And even if you don't have that circle, like I think today, like in the world, there's so much online community on Reddit, Discord, and others where people are ready to help you with anything that comes up. So it's very important to like find that right set of people. And actually, even if they guide you and you don't execute it, then it will not still not make sense. So you have to have that grit and continue to like do those things. And of course, take it bite size, right? Don't like start with like Linux code base. Like start with something small. And like for example, I remember still in college, I did Flappy Bird project, which was very funny because it was RL related, but it was cool and very toy project at that point. So my bachelor's thesis project, which is like fourth year project that you do, was around Flappy Bird, and we were like connecting it to like a controller there. So that was like a very bite-sized project, but it gave me like a good amount of idea on like how RL works and everything works. And you can start with sample code bases and start from there, right? Then I think it's more about like where do you take it from there? Uh, like how do you take that code base and what do you do with it in the future? So adding features and all that stuff. And I think one other thing I specifically did is like be out there. Don't be afraid to share what you have built, right? So I built a lot of open source projects in my time at Roorkee, right? So they were like very popular in general. Like, so I built like a PHP router because I wasn't really doing something, put it on Hacker News, just be out there. Like people shit on you, but like express yourself through that. And a lot of people also appreciate these kind of tools. So once you have a community going, and you are a good example of that, right? You start from somewhere and then you start like small and small and eventually starts like snowballing into something else. So that's the fact. Like you have to start somewhere, keep the grit, have the right mentors, and continue moving from there.
That's amazing. That's great advice. I remember in college you started with JavaScript, jQuery, but then moved to Golang, and then eventually did a master's in ML. So how were you switching stacks? Was there a framework you followed?
Not really. I think I was basically, so I think PHP is sort of like a lab thing where like we were doing PHP because everything in lab was in PHP, and that was probably because of Nemo, because of the time PHP was cool. And I think Facebook also did a lot of investment because all of the Facebook was based on Hack, right? So like PHP was cool at that time, so everybody was using what was cool. And JavaScript, when I started coding, jQuery was the top framework. Then Angular came in. I still remember coding Musi in Angular. Then I think a year or two later, somebody recoding it into React. so so it's more like the frameworks keep on shifting, right? I think the more important point I wanted to make in general is like have your solid engineering principles. So the framework and everything is a tool to execute your vision. But if you're solid object-oriented programming principles and also functional programming principles, you can just pick up any language. It doesn't really matter what it is. Because at the root of it, they have same AST at the end of the day, right? Like looks very similar. Everything gets compiled to same assembly instructions. So if you're coding, this is something I observed over time because I picked up many languages as I progressed through it. Like we weren't really using a lot of Python back then in lab. And like Golang and Rust and all this stuff, because depending on what you want to do, different languages are good for that kind of task, right? But if you have solid principles, so what I'm trying to emphasize is like have a solid foundation. So if you have that solid foundation, everything else becomes easier. So learn how at the root programming languages work. Don't learn Python, learn how to code. So that's the very important point. It's very hard to like, it's because an abstract concept. It's very hard to like put it in words, but what I'm trying to say is like, understand how you code well. Like how do you create interfaces and how do you create good interfaces, and then how do you use like abstractions in a way that your code is sort of like very clean and so on. So those principles follow you everywhere regardless of the language. Only paradigm that I've seen is very different is functional programming, because that you have to rewire your brain to think how functional programming works. But that actually opens up a lot of things on how you write atomic functions, which don't really change output. So that's like a different kind of thing, but that opens up and broadens your viewpoint. So I think the tech stack for me has changed a lot over time. Like I think only thing that probably stuck on the front end side was React, but React also kept on changing with time. Like it's super. Recently, like I looked at React and I was like, oh, this is pretty different now. They use state and like use. There's like all of these hooks now, right? Which change the way React works. So things keep on changing, but it's easy to pick it up if your like core is very strong. Same for like Python, right? Like when I started, the popular framework was Theano, and like on the deep learning side, and then TensorFlow came into the picture, and then PyTorch came into the picture. So what mattered is like how did you write a good neural network code, right? So that basically there were some changes in how you write, and there are best practices about every framework. But at the core of it, they are all same. So you can just start from somewhere and just continue from there. So this is why even if like JAX comes in, and JAX is already there and it's getting very popular, right? So if it comes in, the core fundamental principle of how tensor parallelism and pipeline parallelism work don't change across frameworks. So if you know them well, you can pick up a new framework and then continue. Of course, there will be some friction, so you have to go through that. But it's very easy to do it if your fundamentals are right. So focus on fundamentals, get them right, and like that's why I was picking up a lot of languages in short amount of time, because Golang was cool for doing like concurrency and other things. So I was like, let's try it out. Then I was trying Clojure in my internship in Bay Area. That was very interesting experience. So yeah, I think like over the time I realized number of languages doesn't really matter. It matters is like what's your foundation.
That's very cool. Super interesting. I have a good question. One of the things that I remember about you was, and you sort of ingrained this in me, learning before earning, Harkirat. Don't focus too much on an internship right now. And I think it was very obvious to you you're going for a master's, even though you could see 𝗟𝗶𝗹𝗀𝗀 was just starting. You had like 10 different options to join. You got a PPO from your SF startup. Yet you went for a master's, which is pretty expensive in NYU, I would assume. So what led to that decision?
I think the pivotal point was probably the internship in Bay Area itself. I think I sort of saw that like since my bachelor's was in electrical, like I needed to like get a little bit more understanding, like you said, like have more learning on the CS side at the core fundamental level. And AI was like up and coming at that point, and we had like a lot of exposure in lab to AI, like very initial things, right? Like we had like this project that would scan whiteboard and try to convert it into text back then. Then we had music recommendation system. So we had a lot of stuff that we were already exposed to, and this seemed like up and coming. So I think 2016 or like 15 was the right time to enter AI, because that was sort of like the end of classical ML learning, and then like rise of deep learning in general after AlexNet paper in 2013, right? So it was just still getting up to that, and frameworks were also getting ready. PyTorch, I still remember like when I was in master's, PyTorch version 0.1 was released. So I have been using PyTorch since 0.1. So I think that was like just a bet, I would say, at that point that ML would improve, and I wanted to learn about ML in general, and this is the up and coming field. So my general theory in life, I think, or like a fundamental principle in life is like you should enjoy what you are doing, because if you're enjoying what you are doing, then you will lead to the best thing that is possible in that one, and then the money is a side effect of that. So that's always the fundamental. Like I never chase money, chase what you are learning over time. And I think I remember still Nemo saying something to me, like, which was, I think, still stuck with me since like those days. It's like, he said like, Aman, like if you look at Aman from day ago, and if you don't see, if you're writing verse code, or you don't see like change from day ago, then you're doing something wrong. So every time I made a career change or any shift, like that's the point where I felt stagnated in something I was already doing. I wanted to grow in career. So think about it, right? Like bachelor's was like okay, like it was challenged with electrical and everything, but master's was a different level of challenge because it had capstone projects. Like you had to go super detailed, because education system in US is very different than US, like India's education system. You actually have to do practicals, not just go into the into the lab and not do anything. You actually have to like do assignments, and practicals and everything weighs like 60% of the project. So I took, even in masters, I actually took advanced PhD course, and like I took 3 capstones. Nobody has done 3 capstones because I really wanted to learn. So like you only need 1 capstone to graduate. Then after masters, I wanted to go more deeper inside AI. So I joined FAIR, where I learned a lot about like production systems of AI, like how to do better research, while I worked with Devi and Dhruv there. And then from there on, I wanted to like do something more independent that was not sort of like, there was no like, it had more autonomy in general, right? So we started from there and then Hugging Face. And like Hugging Face, I started feeling more stagnated because I wanted to grow more and learn more things. As a startup owner, you do a lot of things that you will not do in your daily life, like hiring people, like interviewing people, coming up with interviewing panels, like into everything around that, then sales, like marketing. There are a lot of other things. So it's more about like, are you growing every day? Is like Harkirat from yesterday better than like Harkirat today is better than the Harkirat yesterday? That's the important point.
Very interesting. You mentioned college in US is very different from college in India. I mentioned a while back I'm starting a college soon. So my question would be, what is the difference? And did college curriculum at all help you in reaching where you did?
I think a lot. Actually, honestly, I think my master's was very useful for getting into ML. So my highest cited paper is from my master's. So it was 𝗟𝗶𝗹𝗀𝗀. So it has like close to 7,000 citations right now. So it was one of the most impactful papers in NLP in like recent 10 years, which shaped up how evaluation works in NLP. And the other 2 were also very impactful. So my focus, so in the last semester of master, I didn't do anything. I just did research. Like I didn't take any course. I just did research. So the difference is like you can choose your path in your like education here, like what you want to focus on. And the second major difference is there is less focus on theory, but more focus on practical application. So when, like I was saying in the start of this, right, like if you actually execute the theory or like try applying it in practice, that gets stuck with you more rather than like just reading it, cramming it, and just writing it in your exam. That's why I don't remember anything from electrical, because I crammed it and like I still remember. I actually remember the actual practicals we did in electrical, but beyond that, the theory is like gone from my mind, most of it as of now. So anytime I have done some assignment or like actually done something in practice, that has helped a lot in gaining understanding of like what is missing there. Like I still remember, like I did an advanced database course there that required building like a full replication and concurrent like related database. So we actually built a project on that. So that actually ingrained fundamentals of databases really well inside my mind that I still use up to date, even in ML, because you're creating vector databases and few other things, and you are like applying these concurrency principles, because writing good ML training code requires solid engineering principles, because you have to parallelize it, make it like, there's like a lot of nuance there. I don't want to go there, but specifically what I'm trying to say is like focus on practicality rather than just theory is more important, because that stays with you for longer term. Like ask, like for example, if you go to a very simple example, right? Like if you go to anyone who is doing BTech in electrical, ask them to fix a broken fan. They can't.
Right.
But here they actually like show you like how these connections work, and then you actually have to like fix it. Like this is the difference, right? This theory based versus practical based. And because I did these assignments, it also helped me build my GitHub profile on ML side even better, which helped me land fair job and like all of the other things.
Got it. That's super interesting. I think it'll be a while before practical knowledge reaches India at this level. Purely based
I
on
think it's not very hard. You can just change the curriculum and incentives to focus on assignment and practicals. For example, like the exam in most of the courses was only 30% of the total grade. So your assignments over the course, and they were people actually grading them properly, and they would have auto graders and stuff. And then your final project were 30 and 30, and then 10% was attendance really didn't matter. Like in India, there was 10% mass for attendance as well. But it's more like if you're really interested, you will be in the class. So there's no sense of like marking attendance, right? So 10% was for like other things as well. So in general, that kind of like reward structure is like an RL agent, right? You change the reward structure, and then basically like people start behaving that way.
Right.
In India, like if you remember, I don't know if you remember, like exams were 80% of the grade.
Yeah, yeah. Yeah, I think the difference that I can think right now is that the stakeholders have very different motivations. India one curriculum is not very easily changed. It's regulated by the government. I don't know if that's true for masters in the US.
No,
And
they can introduce their own courses. So even like professors are doing research here, right? That's one other major difference. So professors are involved in cutting edge research. So the courses they are creating are also cutting edge in that way because they're sharing the recent research they did with the people itself. So courses keep on changing based on what is the recent uh, advances in AI or something. Like for anyone who is sort of like I want to hear more about what you are saying about like the incentive, right? But like anyone who basically wants to like learn NLP, right? Start learning NLP, they can go to Stanford CS 231N, right? They can just start from there, like 224N, I think, natural language processing course. And the latest iteration of that course will be the latest what is happening in NLP, not something outdated from 10 years ago. So
right.
that's the important difference, right? Like you can go and learn, anybody can go and learn.
That's super interesting. So what you're saying is the curriculum is changing very quickly based on the most cutting edge thing because the professors are the ones who are working on the most cutting edge things right now.
Yeah, that's a part of it. And then also like students are also like one level ahead, right? If something is missing, they ask professors to talk about it.
Right. So the attendance is really high, I would assume.
Yeah, it's generally high because if you miss the lecture, then you will not be able to do assignment.
Right.
And they also check for plagiarism, right? So it's not easy. Like I still remember my fundamental algorithms course didn't involve any coding. It actually involved writing the rationale behind how this algorithm will be solved. There was no coding in it. It was all like just rationales. Like how will this like Tower of Hanoi will get solved and all those things.
That is super interesting. It's very different from what happens here. I think one big thing I would love to dive into is there's very less content roadmap on how to get into ML. That's not true for DSA. That's not true for full stack. I don't know why that is. I think the way incentives or people who know ML really well is not to teach it, but to build products and build startups or work at Fair. So, do you have a high level roadmap to begin with? Then we can dive
Yeah,
deeper.
I think the reason why I think there are good courses in general, but the reason why they are not consolidated is like because ML is still a new field and it was subdivided into multiple fields, right? So you have to pick like what exactly you want to do. But I think recently with LLMs, most of the things have changed. Like the recent generation of LLMs have like sort of consolidated the field. To start with, I think is the thing I recommend is not reading papers just to begin with, because I think most of the information is in papers, but it hasn't been distilled into courses, right? So start with like watching video lectures from 𝗟𝗶𝗸𝗀𝗀, for example. He has like a very good series of like 5 to 6 videos that if you actually sit down and you have great to like go through like 6 hours of those videos, which are very dense and like very well explained in general, you will walk away with a lot of knowledge that you didn't have beforehand. So it's like LLM for practitioners who were not like LLM 101, right? And then the second level of it is to like start doing deeper courses. For example, pick up Stanford's courses on natural language processing, right? So that's a very good course. So that's the one I also did when I was starting, like, and then because that course will give you like full foundation of how like NLP came into existence, what was the classic ML styles. Even you don't need to know classical ML, it's useful to know it because it helps broaden your perspective, like of what was possible in the past and what is possible today and how this journey came to be. So that will require another like 10 to 15 hours of investment, and they have assignments in this case. So do those assignments and they will give you like next level of confidence into like understanding what exactly is happening. So during this course, they will also share papers, but I still recommend like going through lectures first, and then once you're done with this and redo the course, but this time read papers first. So now you have to like learn how to read papers. So there are specific, there is a course on like how to read papers as well. So you can just search Google. And I think that's a very important course because paper reading is an art. You just can't grasp core materials. But even for the seminal papers, right, attention is all you need. There are illustrated versions of those. There is illustrated transformers and annotated transformer from like just search annotated transformer in Google. That's like probably one of the best examples where how you can start on transformer. So again, like with everything in life, start bite size, right? Start with videos, then move to courses. Now that you are like at this position where you have learned everything, start learning about like APIs that exist, right? That can help you build things. So you can think of an idea, like go to awesome list of things, like there are awesome ML projects, like pick one ML project, start implementing it with OpenAI API. And that should give you like a deeper understanding as an applied ML practitioner on like what exactly to do. Now you want to take it to next level. So start hosting models locally, right? Like take like small Llama 3B on your MacBook. You can actually host it through ollama and then start building on top of it. Now you're tweaking the ML fundamentals. So this is more like now if you want to go even for one level further, I think I can write a book on this. Then you can take for example, start hand annotating examples for instruction tuning data. And what you will do is like use Hugging Face or something. And by this time, I think I expect you to be a master in Hugging Face libraries, right? And use those libraries to tune the model now to be more specific to your case. So still, if you have a MacBook with M1 Pro, you can actually run tuning locally on smaller models as well. Now you have that model, deploy it again. Now you get into a cycle and rhythm of fixing these models and improving them over time. Then there are like other things. Now you can start going into core research of the things, right? I think research where you start building new models is the hardest part because you need to have like very core understanding of what is happening in the internals of the models, like how sequence parallelism works, how tensor parallelism works, how model parallelism works. So that's like a very niche domain now. So most people don't need to be there because nobody really trains models these days. They're mostly using existing models. So if you go back from to the start, like there is like videos that you started from, which gave you overview, and then you went into a little bit more depth. So it's more like how do you keep on going deep, deep, deep at each level? So that's how the learning should begin and continue into like deeper levels. So I think 𝗟𝗶𝗻𝗀 videos are really good, even if you don't want to get into ML or do something. It's really good to get an understanding so that you sound smart in conversations.
Got it. That makes a lot of sense. This is this specific to NLP or is machine learning NLP only today?
It is specific to NLP. Machine learning is not NLP today, but everything is mostly powered by transformer architecture, which started from NLP in general. So the first paper that introduced transformer was on machine translation, which is translating from one language to other. So that's why transformers has been heavily influenced by NLP in general. But then we had vision transformers, which converted images to patches, and then everything started being transformer after that. So the major three fields that you probably care about is computer vision, which has been mostly powered by vision transformers these days, NLP, and then reinforcement learning in general. Like there are other subfields like audio related stuff. Video is captured in CV. Audio is a separate thing. But if you have fundamentals of NLP, right, you can actually get into vision also at these days, and then you can get into audio as well, because what does audio does? It basically converts into spectrogram and it passes it. Otherwise, it converts into byte latent vectors and it passes it directly to transformer. So what's important, like I was saying initially, is to get the fundamentals right. In this case, the fundamental is transformer. And if you get that transformer fundamentals right, you can apply it to anywhere else, and you can read most of the papers and understand a lot of things there. And most of the people like these days who call themselves ML people, they are basically using OpenAI API, so they don't even need to worry about anything down there. They are like fine-tuning API and everything else, right? So the ML practitioner basically means me or like someone trying to use OpenAI API and trying to build an application on top of it. So prompt engineering basically is ML engineering these days.
That takes me to my next question, which is what kind of people are you hiring? People who understand GPT APIs and build on top, or go one level deeper?
There are different profiles. My team is divided into like basically four kind of teams. There is one is customer machine learning engineers who are like customer facing. So they have like good communication skills, but they understand how to use APIs, how to improve applications in general. Like they can dive into specifics of things and change knobs to make it work better. Then we have platform people who are like strong inference people, and they understand ML models deeply, but their job is to mostly deploy and keep them running and building applications around it. Then we have applied ML who takes like existing technologies and then integrates it into platform, but they are like deeper, so they basically can tune models and like do other things. Then the core of the company in general has been research from the day of one, because given me my and Dao's background, who is my co-founder, uh, research is focused on cutting edge research, like developing new alignment algorithms. So we recently released a model with LNAI, which is 𝗟𝗶𝗸𝗀𝗀. So it was a mixture of experts model trained from scratch, completely from scratch. And then we released like a new evaluation paradigm. So this is like fundamental new research that we are doing to improve product over time. So depending on where you sit on the spectrum, there is a place for you in the company, right? So researchers are people usually who have PhDs and have like done like many citations and papers in the past. And then applied ML are people who are like who have strong ML background, have done some research in the past, but they mostly have been doing applied ML at certain companies before also. So they are more like, how do I take an abstract problem and I apply ML to solve it? So this is the standard MLE profile, like the machine learning engineering profile. Like I have like a customer support use case. How do I apply ChatGPT to like make it work? Or how do I improve ChatGPT to make it work on my case? Then platform is mostly full stack engineers who have moved to AI and like developed deep understanding of inference. And customer machine learning engineer is MLE but customer facing. So like platform team is a mix of full stack plus other people as well, like for example people who are really good at front end as well. So it depends. I think it's like a combination of things, but they mostly like need to have some basic understanding of how transformer works, otherwise they will not be able to use anything.
Got it. That makes sense. What would you have been working on if not this? What do you think are high value startups that people are building now that NLP or LLMs are a thing?
That's a good question. So I think I can tell you a story of why we started like a focus on enterprises. So generally what happened after ChatGPT is like everybody noticed ChatGPT, and every CEO in the world is like, I need to digitally transform my company and like get AI. I have to like use ChatGPT somehow. But the reality is like once I started looking into ChatGPT and other models is that they were not reliable, and we were talking about this before. Like error tolerance. If you have error tolerance in your use case, then you can apply machine learning as it is today, like code generation, right? If I don't like the generation from the VS Code, like Copilot or like Cursor, I can just ignore it. But in case of like healthcare or other industries where stakes are very high, if you give like wrong prescription, a lot of other things can happen, right? Then you need more reliable AI that you can fact check, you can audit, and then you can also have like some notion of uncertainty on how uncertain it is. And that's how we saw this gap for enterprises, that the current generation of machine learning models is not ready for enterprise use case where the stakes are very high. It needs reliable and be very highly accurate. This is how the company started. So I think basically like in life, it's important to notice the patterns around you of like what is the most important problem to focus on, and then start focusing on that. And I think at that point they were like inference. I think if I wasn't doing this, I would likely be working on inference, because inference is likely the highest impact thing you can do in ML right now, because more higher in the stack you go, less your TAM also becomes, TAM, total addressable market. And then if you keep on going down, if you reach NVIDIA stage, which is the semiconductor, so your TAM is the biggest because everybody will use it. But that's hardware, so I'm not really interested in hardware. One thing I learned over time, I think if you go to the software layer and you have to build better inference engines, that will actually impact the stack all over the ways. One layer above this is OpenAI and other foundation model companies, including us. So we are powering applications on top of us. Now there is Perplexity, like Harvey, and few other companies that have been like on this layer. And then there's the consumer at the end of it, right? So depending on where you're sitting, like I think your scope. So this layer is seeing like a lot of impact on the top as of now, because people are realizing like AI apps are useful, but all of the money is going down the stack in general. Right. So that's how I think about things, like where I can create maximum impact. That's my goal in Meta was also like very similar. Like when I did machine learning research on multimodal, I built generic models that could be applied anywhere, and anywhere they would apply these multimodal models, they would see improvements. So that's like the bottom line impact. So I usually think about from bottom line. So inference would have been like the other thing that I would have focused on.
Very cool. What do you think about, the biggest companies that you can think of right now that are raising really high are either, of course, LLMs or Cursor is doing really well, for example. Coding agents or agents generally is a very big market. You mentioned a while back, customer support is going to be a big market. These are, of course, up this chain. Do you think a lot of the value will accrue at the application level? As you said, a lot of it will drip down to the LLMs.
But I think the margins change, right? Like highest layer has the highest margin, and as you go down the layer, it also gets more cutthroat competition. Like as you look at Gemini costs, right? Gemini is like super cheap now. Like you can like generate 65,000 images in like 50 cents. That's just crazy, right? Like, so the competition down the layer keeps on getting harder and harder because you have to keep on innovating and keep on making more and more changes, and the margins are low. Same for NVIDIA because they get it from ASML and other things, so they have to like take it together and then push it. So you can compete there, but you need to have a lot of capital or need to have like been an incumbent there. So actually, you mentioned Cursor, but the companies which are actually raising a lot of money are not Cursor and others. They are the chip companies or inference companies like Grok and like others. They have raised a lot of money, like the chip companies like SambaNova, like 𝗟𝗶𝗸𝗀. They are raising a lot of money because it's an intensive process. You need a lot of people to do it, and you need distribution and everything else. And as you move upwards, the inference companies like AWS is investing. So you're competing with hyperscalers at that point. So that's like a different level of competition. Like then one layer above foundation models are like OpenAI, Anthropic raising a lot of money, like even contextual in that particular region, right? So depending on where you sit, you need less or more capital, but your margins are also higher. So depending on where you are, if you are also like a little bit agnostic to the stack below, that gives you a lot more power to change it. For example, NVIDIA can't really do much in agnostic fashion, right? Or for example, GCP is focused on TPUs, so they can't really change much there. But Perplexity can change their model to something else tomorrow, like, and then we'll have similar sort of impact. So it's more about like flexibility and market. So going back to your original question, so I think the value will accrue in different layers, and I think we have already seen a lot of training value accrued to NVIDIA. But inference is still an open play between different hyperscalers, but foundation model players is still like getting figured out. So it will get like it will be in different stages, but I think we are already seeing on the app layer because that's most visible.
Right.
So that's why those companies also raising quickly because they have something to show, good ARR and so on, and then but then you don't know how long that value will stuck because that's very easy to build.
Correct.
Like you can see like Perplexity's open source wrappers are appearing, like a lot of them, which are not very hard to build. So at the end of the day, technology, this is something I keep on telling my reports as well. Like technology is not the moat in the longer term. What matters is the domain knowledge of the domain that you are in. And this is what we call tribal knowledge generally, like the knowledge of the tribe that nobody else has. And then the data that you have. Like, for example, like what are the students learning in India today, right? That kind of data, that cutting edge data that you have that helps you make better decisions about technology can help you move forward much faster. So technology will always not be a moat. See OpenAI, right? Like huge, like edge like 2 years ago. But now, like everybody is almost similar in models. Like models will become a commodity, right? So it's very hard to keep technological moat because if there is money, people will appear.
Right.
So, and that's why data mode is what OpenAI really has, and that will keep them at the edge there.
That makes a lot of sense. I have a small section after this, which is going to be 5 things that come to the top of your head. So 5 papers that you think everyone should read.
Attention is all you need. I think GPT-3 paper. And then in CV side, I think everybody should read AlexNet because that was the first paper. And I also think like Yeah, other two would be, I think these two are like really important, and then you can, depending on what exactly you are looking to do, it changes. Like, for example, you should read vision transformers if you are into vision, right? And then, of course, like I think AlphaGo on the RL side are like super important papers. Like those are the foundation of like how reinforcement learning works. So it depends on what you want to do. But the five papers, like in that sequence, because they keep a lot of breadth, would be attention is all you need, and then you need GPT-3 paper and how it is done, and of course like Llama 3 report as an extension, right? So you should read that. AlexNet, Vision Transformers, and then AlphaGo papers, the series of papers. There's not one paper, there are multiple papers, so doesn't really go. Yeah.
Got it. Five libraries that you use very extensively in your work.
PyTorch, a lot of NumPy, and actually I use 𝗥𝗲𝗬𝗀𝗀𝗀 a lot. So it's like a wrapper around things that will basically helps you visualize things. Hugging Face transformers, data sets, and then finally I think React. I still use React a lot.
Got it. All right. Five open source projects that you think people should read through, contribute to.
Yeah, I think the best one to read through if you really want to learn coding is still Linux. I think core. I think that's like very important. You should look at like the bug file and like how like security patches are done there. Like just reading through a security patch will give you like a lot of information. PyTorch is a good one to look at and how they have structured all of these things, but they're very big packages, right? So not small. I think the other one that comes to top of my mind is NumPy because I really like the library and how well it has been implemented. And then of course Transformers because Transformers as a code base is a very different kind of code base, like how they've structured their files. They don't follow any abstractions, to be honest. They're like very minimal abstractions. So it's important to understand how do you make researchers work well, because if you add too many abstractions, it loses the flexibility of like modeling. So that's a good code base to learn how to like make researcher first code base, right? And then of course, I think there are like more core libraries like DeepSpeed. DeepSpeed can use a lot of help in general. That's like very heavy. It has powered a lot of training side of things, but in general, it needs more love from community.
Got it. Very cool. You mentioned a few roles you're hiring for. You mentioned you have like 50 engineers right now. If someone today, let's say, knows coding well, but does not know ML, what is the most actionable way for them to learn the right things? What are the things they should learn to get hired at Contextual, let's say?
Yeah, I think the most important thing is to show curiosity. So show what you have been doing in the past, and it's not about how much you know, but how much you're willing to know. So how much of a grit you have. So we actively capture that in our interview process as well. So we are looking for the right people with the right mindset who are very excited for AI in enterprise potential. So if they want to like join Contextual, it's more about like understand PyTorch fundamentals, understand how language models work. So like starting with 𝗥𝗲𝗀𝗀𝗀𝗀 lectures and so on. And then also like, of course, like understanding how ML systems work. So like how does the state of the art inference looks like? How does state of the art caching looks like? What is like for example, we were talking about open source project. The one I should have mentioned is VLLM, which is like a very important project in inference ecosystem, like how VLLM works. And then of course, like having concrete thoughts on like what do you want to do with your role and what do you want to focus on in the future. So all of that stuff matters.
Got it. And considering coding is becoming very easy these days, have you seen hiring go down in your company or generally around SF when it comes to engineers?
So I think I would not say coding is becoming easy. I would say we are able to code more and fast. So that is the difference. So what happens is like generally like what happens, right, in any technology, you instead of focusing on like details, you started focusing on higher level things, right? For example, like now we have a cell phone in our hand. Before we used to remember phones, we were wasting time to remember phone numbers and then we would dial them. So there was a lot of time wasted into like menial tasks that didn't really matter. So once phone came into picture, like mobile phone comes into picture, they help you save all of this time, right? Same for AI. AI will help you save a lot of time in short term and do tasks that you were doing before, so that you can focus on the things that matter in your life, like for spending time with family or like thinking longer term strategies, right? Like what would my code base look like and what does my code base need to do in a longer term and how will I achieve with that AI? So I think the logical reasoning part hasn't really changed. It's more about like the implementation of that logical reasoning has changed. So we as software engineers are logical reasoners at the end of the day. We are building logical code paths and we are executing those logical code paths. So what we are taking is the logic in our brain and writing it in the code, right? So what is changing is that we have a mechanism now that can help us implement it way faster. So if you think from that perspective, the job description will change, will move towards thinking more about logic, more efficient logic, and then somebody else or the mechanism can implement it. But I think like coordinating with your teammates, coordinate with plans, like coordinate with long-term visions, all of that stuff will not change. So here's a good way of thinking about what will get automated by AI and what will not. So if your job is heuristics based versus algorithmic, so heuristics means like every time you have to change your approach. You're doing something, you have to change your approach. Algorithmic is like, I do same thing every day. Customer care, like, for example, like even like checkouts, right? Like grocery checkouts, like transcribing. I do same thing every day. There's no like change in life. So it's algorithmic tasks. Most of these algorithmic tasks have been offshored to India or something. These tasks will easily get automated because there's no heuristics involved. You don't have to change your decision based on the inputs, right? So it's very fixed menial kind of tasks, right? So those tasks will get automated, but a heuristics task, which like, for example, you probably do every day to decide what's the future of the company, right? Like where do we go? Like what video I need to record today, right? That kind of stuff, it changes based on the recent patterns, requires processing a lot of inputs, and every day looks different. Same as the life of software engineer. Every problem looks different. So those will not go away in any short-term time, because what will help there is building context in the AI, and still there will a lot of context of life missing there, right? So this is what contextual focus is on, building context in AI itself. So wherever like heuristics is required, that will be very hard to automate in short term.
Got it. And what about long term? The next 5 years?
Long term, I think, of course, like it will be like an agent with you, right? Like learning everything about you. So it will have like long term memory, and like everything will change based on that. But you will be the one still directing this agent into doing some things, right? So then you get more time to spend on things that matter in life. Of course, like I think Sam Altman has a good essay on this, like what will happen once like AI actually comes into picture. Like everybody gets time to spend on more things, like more hobbies, reading, all this stuff. But in general, like do more work that actually matters. So like do things that you enjoy, like building YouTube videos or something, right? Like that's the kind of stuff you can do. But software engineering as a core will not go away. It's more about the nature of the job will change.
Got it. Makes sense. Yeah, that's all the questions I had. Thank you so much. Usually 5 minutes for if you have any questions for me, Neither we can call it.
Yeah. So how are you thinking about ML?
Oh boy, I'm very far from the action. Though I've just used everything on on top of GPT APIs. I've followed startups. I told you I joined Devon recently as an advisor. So I'm seeing all of these startups that are doing well, but none of them are building foundational models yet. But यहाँ पे, even though the TAM is, as you said, much smaller, there will be a lot of competition here. But startups are blitzscaling really fast. As I mentioned, Cursor. Then there are front end. Similar like products in front that let you build React front ends very quickly, which are also solving a very specific problem. But I don't think anyone is building models yet, and most engineers probably there are not ML engineers. So I've seen that action from the sidelines. I've seen people get very anxious on YouTube. Our jobs going away, software development is becoming faster. So however, I do have a little bit of FOMO of not going for a master's or a PhD now. Seeing if you remember Karan Desai, other people from my batch who went for it. So this is my current understanding from the sidelines.
Yeah. So Karan is also joining a startup now, right? So he's in World Labs.
Oh, I thought you were starting up.
No, it's a early stage startup by 𝗟𝗶𝗸𝗀𝗀.
Got it. Makes sense. So yeah, but I think
So that's where he already finished his PhD.
very cool. Yeah, I think
Yeah, so I think other question I had was like how do you build more machine learn like or how do you train more machine learning engineers in India? Because what you are saying is actually is a problem because when people ask me like why don't you offshore to India, right? Like some of these things, like I think the major reason is that the talent is missing there. Like we don't have that level of depth that we need for our particular because we are in different stack in different layer of the stack, right? If we were higher in the stack, then that would be a different story. But that requires like deep machine learning expertise. So depending on like how will you build more machine learning engineers in India?
yeah, that's the need of the hour. I think YouTube distribution is the best way to get to students, especially the next set of students. Now India has become, not back then, but today most people are learning from YouTubers who have like a lot of distribution, be it DSA, web development. The problem is there's no very big India YouTuber who's been able to grab, who has the credentials and has been able to grab, distribution on YouTube. I have seen a few people. I think someone from NYU only, I forgot the name, some chai and papers or something like that, but don't have too many followers. So there's definitely a need of the hour. Someone who's at your level or half as good as you does this consistently on YouTube, then within a year we'll have there'll be oversaturation. Then there are too many machine learning engineers from India. So if you know someone who'd be willing to do content, willing to start a channel, that'd be great. If you have engineers who'd just be willing to share a little bit of knowledge with me, let's say an hour every week, so I think I can also pick this up. But yeah, definitely need of the hour. No one's really good at ML. Everyone's like very fatty courses right now, Gen AI courses. No one's really solved the problem in India in Hindi yet.
Yeah, that makes sense. I mean, I think there are like startups that are trying to build foundation models like 𝗟𝗲𝗃𝗀 and all these things, right? But I think fundamentally, I think it doesn't really make sense to compete at the foundation model layer anymore because those models will keep on improving with time. And as we get more and more data, like I think they will just be better over time. So it's more important to think about like how do you apply and what is the edge there, right? What is the longer term moat in that particular case? So it's important to learn these fundamentals data. And I think in a year or two, fundamentals wouldn't even matter because everything will be encapsulated in behind an API.
Right.
So what will matter is the libraries that you use to build these applications. So I think an important project to look at is Llama Stack, which is sort of like going to next traction. So think of like PyTorch for language models.
Got it. Nice.
So they're basically providing stack components that you can just stack on top and then you build applications there. So you don't even need to worry what is underneath.
Got it. Is it similar to LangChain?
It's a little bit different, but close to that. LangChain is, I think, more involved. Llama Stack basically would be like, think of it like linear layer in neural networks, right? Like it's just like LLM becomes a layer and then you're basically creating stack on top.
Got it. And when you say stack, what do you mean?
Stack, I mean like a orchestration of multiple LLM calls or something to build something good. Basically an agent in that field.
Got it. Yeah.
Agent is also fancy term, right? It has broad definition.
Yeah, exactly. Makes sense. Yeah, okay, that's super interesting. That's a project I'll look at. And you're saying most people will stay here only. No one will go below this, or no one needs to go below this.
I don't think it makes sense unless you have like huge distribution or you are an incumbent and you have like a lot of money sitting with you. So like all three of those factors, because distribution matters and incumbents have distribution. A good example is very good example is Spotify. A lot of companies were doing podcast audio transcriptions, and all of those died with one move from Spotify. Because where are all of the podcasts on Spotify, right? Like, so if Spotify adds that features, it kills everything out of the box. Same for anyone who is doing something on top of something, they have a dependency on that something to be successful, right? So anytime you have a dependency, that creates an issue. Same for like vector databases, right? So if you think about it, like if OpenAI introduces vector databases in their API, then why would anybody use like a separate like a vector database, right? And then if like normal databases introduce, which they are vector database capabilities, now you get them out of the box. Why would you pay for a separate one? So you're getting squashed from both sides. So that's why I think in narrow modes don't help. You need to have data and tribal knowledge mode in the longer term.
That's very interesting. That's very interesting.
जैसे तेरे केस में भी है ना, right, कि if you think about it, you know how to reach subscribers in ये चीज़ इतनी easy नहीं है replicate करना, because once you have like a follower mode, it's very hard to replicate that. So you are already in the ecosystem. Even if your tech changes, even if you change something, people will follow you across. So that kind of modes are hard to build. That's the mode that survives. क्योंकि AWS का भी क्या मोड है, GCP के पास भी तो same applications, but why do still people go to AWS? Reliability, because people trust AWS. So modes are not technological, they are more around like other traits like trust, like following. People trust you with content, right? So that's the kind of stuff that people care about.
Got it. Yeah, that's a super interesting. Having a kid, like your productivity, what's your thoughts there?
That's a good question. Somewhat, but I think it's more of, I think I really grateful for my wife here, because she puts in extra hours to make sure like baby is fed and everything, so that I can focus on what matters. So I think if I didn't had her, everything would have been different. I think in general my productivity has increased after marriage rather than decreasing, because like a lot of other things don't have to worry about. So I think there's a lot of sacrifice from my family and my wife in making sure that I am actually succeeding. So these are like background people that you never see, but these are the ones who are actually making it succeed. So with baby, I think it's actually, it takes a little bit of time, like, because when only two of us are there, then it's a little bit harder, because then somebody has to take care of the baby. So, and she also needs a break. But I think you can get help from nanny or something, and that helps a little bit. But she mostly takes care of the baby. That helps a lot. That's why I'm sitting with you doing this podcast. Major point मैं ये बोल रहा था कि life में support system होना बहुत जरूरी है. So if you have like a good support system, cherish those people. वही बाद में काम आते हैं.
What a beautiful note to end the podcast on. Thank you so much, Aman, for joining, and people
Thank you. Yeah.